I'm going to hit the record button, and they are all recorded. And incidentally, that GoToMeeting, if you're familiar with GoToMeeting, you can minimize that by hitting the two arrows in the upper right. Not the X, but the two arrows that are right next to them. That acts as a toggle switch so that it minimizes it and doesn't take up as much of your screen. Okay, so should we look at this first problem?
Yeah.
Okay. So what can we notice from the ball? You did it, not quite sure how you did it. You probably did 500 divided by 400 to come up with this 1.25.
Yeah.
Okay. I tell you what I like a little bit better is, and I'll show you why, is 400 divided by 500, because that is 0.8. And what that tells you is that every single time the ball bounces, it bounces up to a height that is 0.8 times its start. So the first time it bounces from 500 meters, multiply that by 0.8, you get 400. Multiply 400 by 0.8, you get 320. Multiply 320 by 0.8, you get that. Now, the way you did this is okay. It's going to give you the correct number. But what if they'd have said, what is the 77th bounce?
Yeah.
It would have been awfully hard to do it that way. So what is an easier way to express it? How about if we take the starting distance and we multiply it by 0.8? Well, that gives you 400. And multiply that by 0.8. Well, that's the same as multiplying it, the original, by 0.8 squared. So if I wanted the distance after the second bounce, I would do 500 times 0.8 squared. Do you have a calculator in front of you, Brett?
Yes.
What kind? What are you using?
It's just a normal one.
Okay, but it lets you do exponentials?
No.
Well, you don't need an exponential calculator. Go ahead and take 0.8 times 0.8. You get 0.64.
Okay.
Then multiply that by 500.
Okay.
And you get 320, correct?
Correct.
So if I did 500 times 0.8 to the third power, I'm going to get 256.
Oh, that makes sense.
So what we want to do is 500 times 0.8 to the seventh power. And that is, yeah, you got to be a little careful here that you don't get off by one bounce. We can see that the first bounce gives a height of 400. So that's definitely 0.8 to the 1. So the second bounce gives that height. So the seventh bounce should be 0.8 to the seventh power. Can you do that on your calculator?
Yes.
Okay. And multiply it by 500, and you should get this number that you had down here. 104.85.
I think maybe I did too many.
Okay.
Yeah, I didn't check this math 4, 5, 6, and 7, but I'm quite certain that that is the height on the 7th bounce.
Okay.
Okay,
So would the equation be y equals 500 times 0.8 to the x power?
yes, where x is the number of bounces.
Okay.
So you're doing it where x is equal to 7. How high is it on the 7th bounce? Now, this equation you have right there, she probably didn't take off any points for that. Is that correct?
I'm not sure.
Well,
I think
notice
she did.
why she might not have taken off points. That's the same thing as 0.8 times x. It might have been better to say y equals 0.8 to the x power. That's really the equation. It's not x divided by 1.25, it's 0.8 to the x power, excuse me, it's 500 starting height times 0.8 to the x power. That's what you really should have put in for answer A.
Okay.
Especially given the title of this, that's exponential exams. So you don't want, that's x divided by 1.25 is not an exponential expression.
Yeah.
So you know your answer for A needs to be an exponential expression. And what that means is that the variable x needs to be in the exponent, like
Okay.
it is in the bottom right.
How
So, okay. Is that an x? That green is an x?
No, that's a star.
What's that mean there?
Oh, that means it's wrong.
Okay, and that means it's right?
Yes.
Okay, well, that should have been the number you got. Doesn't say, it looks like you got 104.85. Is your teacher just automatically wanting you to round it to the nearest tenth? Oh, the nearest tenth. I just see it. Okay, that's how you got 104.9. Okay,
Yeah.
well, that certainly should be this. Now, it may be that you're putting that into your calculator wrong if you're not getting that number, 104.85. The way to do this is to put that into your calculator to start with, 0.8 raised to the 7th power, and then take that answer and multiply it by 500.
Yeah, that's what I got.
Okay, good. And the advantage of using this equation, y equals 500 times 0.8 to the x, is you could answer whatever bounce they want to ask you. You know, like I said, if they ask you the 77th bounce, it's going to be hard to do it that way, right?
Right.
But you could certainly do it this way quite easily.
Okay.
Okay, so let's look at the second one. Let me scroll up here and take a snapshot. Now, if we're doing problems where you have not missed it, you've got it right, be sure to correct me so I don't waste time doing it. I'm not sure.
Okay.
I can always tell. It looks like you missed option 1 here. So
Right.
let's look at this. You're going to start with 10 cents and you're going to double the amount on the first day, double it again on the second day, etc. Well, let's just look at a couple of, okay, I like what you did over here, except you didn't double it each time. You doubled the second day, but the third day needs to be double the second day, so that needs to be 40. And the fourth day needs to be double the third day. You see what's happening here?
Yeah.
In other words, it's not just going up linearly, it's going up exponentially. And that's what's special about exponential. Well, how did we do that? We did it by 10 cents times 2 to the x power. Now, let's see if that works. So they double it, and this is always the crux of mathematics, is once you come up with an answer, make sure it works. In other words, I know that this over here is correct. Okay?
Okay.
So this formula, this exponential formula that I'm coming up with, better equal this table. Well, on day 1, they double the amount on the first day. So actually the table, that should say 20, right?
Right.
And then that should say 40. That should say 80. And let's just cross out everything else. We don't need the others yet. Okay. So does this represent the correct amount on day 1?
Yeah.
Yeah, because when you plug in a 1 for x, you get 2 times 10 cents. That's 20 cents. That's what they agreed to do, is double it on day 1. So on day 1, when x is equal to 1, you better have 20 cents. Now, double it again on the second day. So when x equals 2, what does y equal?
40.
And it should. That's what it's equal to, 40 on day 2. And when x is equal to 3, what is y equal to?
80.
0.80, I guess, or else 80 cents. There's nothing that says you have to put it in dollars. So I could have left that as 10, and then just everything is cents. As long as you know what the units are, that's what's important. Okay?
Okay.
So that's the correct answer for option 1. Now let's look at option 2. You have $10 on the first day. Well, that sounds like y equals 10 times. Now this time you're not doubling it. You're just adding 10, right?
Right.
So what we really have is 10 plus 10 times x, where x is, you know what? You don't even have 10. You just have this. You have 10x. Now, when x is equal to 1, you have $10. Satisfies that. When x is equal to 2, you have $20. When x is equal to 3, you have $30. That is an algebraic equation. That is not an exponential equation. Okay? And there is actually a big difference between the two. Now is as good a time as any to teach you the difference. In an algebraic equation, your variable is on the line, the algebra line. You can solve those algebraically. When it's in the exponent, like on the left, you actually can't solve that algebraically. Most of those you need logarithms to solve. So very important to distinguish between exponential equations where the variable is in the exponent, or algebraic equations where the variable is on the algebra line. Now, the only thing that I see that's wrong with this answer, she gave you a star, but I would have liked to have seen that.
Okay.
In other words, it is not y equals 10y. It's y equal 10x, where x is the day.
Okay.
You can't really have y equal 10y. That never is correct except for when y is 0. Any other number, and that's never correct.
Okay.
Okay? So when you have an equation, always make sure your y is on one side and your x's are on the other.
Okay.
She looks like gave you the benefit of the doubt there. It's one of the reasons I'm not real fond of x and y, because it's too easy to have them look exactly the same. You know, if you don't draw your y perfectly correct, it ends up looking too much like the x or vice versa. Okay, so we've done option 1 and 2. And remember what option 1 was. We got to be careful here that we don't switch units. Option 1 is in cents. Option 2 is in dollars. That's important.
Okay.
So we want to keep this in dollars. And so that's why we're going to use 0.10 instead of 10, is because we want it in dollars. Now we'll be able to compare the two. Okay, they say you can do this for 1 week. Okay, so let's figure out what that is after 1 week. Take 2 to the 7th power, multiply it by 0.10.
12.8.
And now let x equal 7 in option 2. Or not 7, yeah, 7. What do you get?
70.
Yeah. So, which option is correct?
Option 2.
Option 2. Merely because it's bigger. It could have been 70 to 68, and you would have taken option 2. Now,
Okay.
the weird thing about this problem that I don't particularly like is that exponential growth almost always rapidly exceeds linear growth. That's linear growth. Now, what would be really nice, there we go, answer C. What if they offered you this for 30 days? Now tell me what option 1 gives you when you put an exponent of 30. In other words, when you take 2 to the 30th power, multiply it by 0.1, what do you get?
Wow.
Yeah, exactly. Wow. What is y?
Right, it was to the 30th, right?
2 to the 30th, and then multiply it by 0.1.
$107,374,182.
Okay, and now 10 times 30
is,
300.
Look at the difference now. And what this problem is showing you is how powerful exponential growth is. It's just that x has to get beyond a certain number. In other words, when x was 7, option 2 was quite a bit better, $70 versus $12. But when x was 30 days, just 30, my goodness, your parents would have been bankrupt. They'd owed you $107 million, whereas option 2 would have been a mere $300.
Okay.
So that is illustrating the power of exponential growth. All right. Now, Brett, is there anything else you'd like to go over tonight?
I emailed you a second page, David. I screwed up the email address, so you probably didn't see it until.
I can open it right now, I think. Don't see a second page. Oh, yes, I do. Huh. I must have opened it, not realizing that it was a second page. No, that's the same page. So we only have 5 minutes anyway. So it's not terribly important unless she has a particular problem that she'd really like to look at.
Yes.
She can verbalize it even. I don't know.
Can I take a picture of it and send it to you?
Yeah, absolutely. That's what you want to do. That's the best way to do it. Or have your mom do it. Yeah, technology is a wonderful thing. You wouldn't have been able to have tutored online 10 years ago.
No, this is
without a great deal of trouble. You know, you needed to scan an image in, whereas now you just take a picture with your phone and boom, I have it. In fact, once you type in my email address once, it should remember it. So the next time you type in DA, should give you a default option that gives you my full email address. Kristen, do you have any questions as to how this works?
No, this is fantastic.
Yeah, in terms of payment, do you have a PayPal account?
I don't.
Okay.
But I can get one.
Well, that's probably going to be the most convenient for you, is to open a PayPal account. It's just basically a bank that's online. And then, of course, you have to fund it. But then you can pay me very easily, much easier than writing a check, putting it in an envelope, and mailing it to me. So from your point of view, I would suggest open a PayPal account.
I will.
If you really don't want to do that, I'm perfectly willing to have you send a check if that's your preference. You don't need to. I'll send you an invoice if you want to go ahead and set up another session. That's fine. If you're gonna pay by PayPal, I prefer paying in advance. But if you're gonna pay by check, I'll send you an invoice afterwards, and you can send a check.
Okay. There's the second page.
I got the second page. Let's have a look at it real quick and see if we can address a specific problem.
I think number 4 is the one that she is struggling with.
Huh. First of all, number 4 is going to involve quite a bit of math. What you want to do is take it variable by variable, Brett.
Okay.
Okay, in other words, deal with your numbers first, and then deal with all the m's, and then deal with the p's, and then deal with the q's. Come up with an answer, and then make sure that they all have positive exponents. Looks like you got all 3 of these right. Isn't that? Oh, that means wrong? Yeah, that means wrong. Okay, so let's go through it. You need your rules of exponents, okay? But the number is the first thing we're going to deal with. Well, there's only one number there. It's 4, and it's in the denominator, okay? I'm going to leave it there. Now let's deal with the m's.
Okay.
What is m squared divided by m to the minus 2? How do you do that?
Wouldn't it just be m?
You subtract the exponents, correct?
Correct.
Okay, what is 2 minus a minus 2?
4.
So, and that goes in the numerator. All of these are going to go in the numerator as I go through each variable. That takes care of the m's. What is p divided by p?
Nothing. 1.
It's 1. Anything divided by itself is 1. So there's a 1 in the numerator. I don't need to write it. Takes care of the p's. What is the q's? Subtract the exponents. You got minus 1 minus a 3. Go ahead and use your calculator if you need to. When we have more time, I'll review this, because you want to be able to do this without a calculator.
Yeah.
Very, very important that you know how to do this. You really can't succeed at algebra if you don't know how to do minus 1 minus 3. It's minus 4, okay? And that initially goes there. You with me?
Yep.
So that would be my answer, except for the instructions. Use only positive exponents. So we have to take this q to the minus 4. How do I turn it into a positive exponent? What do I do with it?
Put it into the denominator?
Exactly. So the denominator becomes m to the 4 all over 4 times q to the 4. And there's your answer. So just take it constant, then the next variable, and the next variable, and the next variable. They could have 10 variables here, and it wouldn't matter. It wouldn't make the problem any harder.
Okay.
As long as you take it one variable at a time, you'll be fine. Now, what does that mean? 1/2 to the negative 3. What's a negative exponent mean?
It'll be negative?
Means I'm going to put it on the other side of the fraction bar and use a positive exponent. So that's what I'm looking at.
Okay.
Now, what's 1 over, first of all, what's 1/2 cubed?
5 to the 3rd.
1/2 times 1/2 times 1/2. What is that?
0.125.
I don't want a decimal. Give me a fraction.
1/2 times 1/2 is 1/4. 1/4 times 1/4 is 1/8. 1/8.
1/8?
Yeah. So this is 1 over 1/8. How do you divide by a fraction? You flip and multiply. That's equal to 8. That's why I didn't want a decimal, because the problem was much easier as long as you left it in fractions. So the answer is 8. Okay. Now, the very last one here I'll cover real quickly. This is what I kind of call double exponentiation. What you're going to do is multiply that times the exponent of everything that's in the parentheses. Well, the 3 has an exponent of 1, so it's going to be 3 squared. The n has an exponent of 5, so I'm going to multiply 5 times 2, so that's n to the 10th. And then the a has an exponent of 1, so I'm going to multiply 1 times 2, that's going to be a squared. And the only thing I can simplify is that becomes 9. So my answer becomes 9n to the 10th a squared.
Okay.
Awesome. That's great, David. I followed along, so I think I can do it now too.
Okay. Well, that's the way it works, and you have you've figured out my website, how to schedule an appointment.
Yeah.
And
Love it.
so I'll just leave it to you and Brett to figure out when and how often you want to schedule sessions.
Thank you so much. This is awesome.
Our sessions work quite nice. Our sessions work fine also, as long as somebody can focus for a full hour.
Got it.
The cost is the same. In other words, the hour session is exactly twice what the half hour session is.
Yep. Oh, thank you so much. This is fantastic.
Okay.
We will definitely be booking you again soon, and I'll get my PayPal thing set up.
Okay, Kristen.
Okay, thank you so much.
Brett, and talk to you later.
Thank you.
Bye. Thank you.
Bye-bye.
That was pretty awesome. What do you think?